Hi, welcome to this exercise on WaPOR Precipitation Data Validation, which is part of the open courseware entitled WaPOR Concepts and Validation. My name is Solomon Selim. I'm a senior lecturer at IHE Delft Institute for Water Education. In this exercise, we use a Python script to download WaPOR precipitation data and compare it with 14 stations data from the Global Historical Climatology Network daily. Therefore, you need a Gmail account to be able to use Google Colab. You also need WaPOR API key to download data from WaPOR. Please refer to the OpenCourseware on water productivity and water accounting using WaPOR for details on how to access WaPOR data. You also need to download the data files in the notebook from the OpenCourseware and unzip it in a directory where you can easily access. The data from the Global Historical Climatological Network daily are provided in a daily time step. The data has been resampled to monthly time step for this exercise. You can read more about the Global Historical Climatological Network in the link provided. And the data, the station locations of these 14 stations from the GHCN are indicated in the map here. Now I will go to the Google Colab to run the script. I downloaded the precipitation validation data, which is named precipitation_validation.zip, to this directory, and then I will first unzip this zip file, and then when I unzip that file, I will see 3 files, 2 of which are zip file and one is a Python notebook file. So this is the file which I need to first upload to Google Colab. To do that, I will go to a browser and then search for Colab. And then when I open the link to Colab, I will see something similar to what you see here on the screen. So this is the front page of Google Colab. Here I can upload the notebook file which I wanted to run. To do that, I will go here, File, and click Upload Notebook, which gives me the possibility to browse to the folder where I saved the notebook. So this is the notebook which I wanted to upload. I'll select that, click Open. It will take a few seconds to upload the notebook. Okay, so here is the notebook which we will use to validate precipitation data of WaPOR by comparing it with gauging the stations from the GHCN daily dataset. The first thing we need to do is to install the required package on Google Colab. So if we run the first cell, it will install the required package on Google Colab. It will take a minute or so to complete the installation. So we need to wait for the installation to complete, and once the installation is complete, we can go to the next cell and run it to import the required package. It's still installing the required package. It may take a bit more time depending on the, I guess, the internet speed or so. Yeah, so when we see this green tick mark, that means this installation or running of this cell is completed. So we can go to the next cell and run that cell, which should be very quick to import the required package. And then the next cell is to upload the files we need to Google Colab. So Google Colab run on the cloud, so we need to upload the data files which we use from our computer to the Google Colab on the cloud. So to do that, I can run this cell and I can choose the files to upload. When I click this, it will give me the option to select files, and here I will select the data.zip and the WaPOR download.zip file. The data.zip file contains the data which we use to compare WaPOR with GHC and the data, and also the WaPOR.zip file contains files of Python script which help us to download WaPOR data. So I will select the two zip files, click open, and then it will start to upload the files. Okay, now uploading the files is completed. The next step we need to do is to unzip these two folders, because these zip files contain several files under them. So if I click the next cell, it will unzip these files into the respective folders. The next cell, we don't need to run it. This is just to, if we wanted to, for example, delete a folder in Google Colab, we can use this kind of command, but for now, we don't need to do that. So I will move to the next one. The next is also in the data file. What is included is a metadata about the stations which we downloaded from the global historical climatological data. So if I run that, I will have the metadata file which indicates the station code, the longitude, latitude, and elevation of the stations, and we can convert this information into a data which we can plot to see the locations of these stations. So when I run this cell, I can see the stations are located, some in Ethiopia, some in one in Kenya, some in the Southern Africa, and a few of them in the West Africa. So these are the stations where we will compare WaPOR data with the station data. So the next step is to start downloading the WaPOR data. For this, it will ask you to provide WaPOR API token. So you should have this API token, you should have created and saved that token somewhere in your computer. Now I saved my token in my computer, so I can copy and paste it here. And then this API token is now saved. So the next, if I run the next cell, it will start downloading the WaPOR data for the corresponding stations, which are shown in this map. This will also take some time to download the data for all the 14 stations. What this part of the script does is to access WaPOR database, download the data for the longitude, latitude, location of the stations, and save them in a folder in Google Colab. Now we have finished downloading the data, so the next step will be just to compare the station data with the WaPOR data and compute some metrics. So this part of the code will just do that, compute some statistics, and also plot, scatter plot for visual comparison. Okay, so that part also is completed, and this is the result for the last station. But if we, for example, go and look at the data here, we have in the monthly folder, we have the monthly values of the WaPOR data and then the data from the stations. And in the plots folder, we have scatter plots and time series plots for each comparison. And also we have a file which is called results.csv, which shows the statistics computed for the comparison of WaPOR data with each station. So the correlation coefficient, the root mean square error, the NAC bias, and so on. And this shows the sample size and the value. So we have 172 months of data to compare for each station. So in the last part of the script, what we can do is to download these plots, both the scatter, the time series plot, and the result file to our local folder, because the result is now still in the cloud. So if we run this cell, the last cell, it will zip everything which is included in the plots folder and download to our local file in a local folder, so that we can easily access these plots in the result file. So now it's downloaded. It's the name of content. So if I extract this file, then I can see these two folders, scatter plots and time series, and the result files. For example, if I want to see scatter plots, I just go and open one of the images, which will show us like this. So for this one is, for example, precipitation from GHCN, and the x-axis is precipitation from WaPOR data for the station with this station ID. The location, longitude, and latitude are given here, and then some of the statistics are also shown here: the percent correlation coefficient, the root mean square error, the bias, and so on. So by looking at this scatter plots and also the statistics or the metrics computed, we can judge the quality of WaPOR data as compared to the station data which we get from the GHCN network. Okay, after running the script and getting the results of the comparison, you can try to answer the questions posed earlier. Based on the results of the comparison, for which stations WaPOR precipitation compared better and for which stations the results are poor. From the result, what would you say about WaPOR precipitation data? What do we need to know about the reference dataset to conclude if WaPOR precipitation represents the actual condition on our area of interest? Do you think the duration of the reference dataset is long enough to make robust statistical analysis? What factors do you think would contribute to uncertainty of precipitation data from WaPOR? This is the end of the exercise on WaPOR precipitation data validation. Don't forget to check out other videos and resources from the open courseware to learn more about WaPOR concepts and validation. Thank you very much.